Hey, what's up everyone? Welcome to the course of microservices with Springboot. This course is going to be in-depth course from beginner to advanced level from Springboot to deploying the microservices. In this course, we are going to cover how to start working with the Springboot, how to create the Springboot projects and how to create the different APIs, how to create different REST endpoints in this course. And then we are going to learn more about the Springboot and Spring Data JPA, how we can create the different REST APIs and connect all those REST APIs with our backend, that is our database. We are also going to learn about the basics of web services and then we will move towards the microservices. We are going to see what is microservices and what are the advantages and disadvantages, and we are going to create the microservices architecture. We are going to create multiple microservices and we are going to connect all those microservices together. We are going to use the Spring Cloud as well in this microservices. So we are going to touch all the different components of Spring Cloud and we are going to implement all those in our microservices. So we will see how all those things work together and create the entire microservices architecture. Then we are going to learn Docker and convert our application into Dockerized format to convert our application into containerization so we can deploy our applications into Docker. And we are also going to learn Kubernetes, how we can orchestrate our containers and deploy all those into a Kubernetes cluster. And we are going to deploy our entire microservice architecture, what we have built, into a Kubernetes cluster. And we are also going to implement each and everything with the automated CI/CD pipeline. So this is the agenda of the course. And if you want, you can go through any of the topics that are mentioned here. If you already know about the Springboot, that you can skip these topics and you can directly jump to the microservices. If you know the basics of microservices and you want to go ahead and jump towards the deploying the microservices, you can go ahead that way as well. And you can also go directly to the last section about deploying all those using the CI/CD pipeline. But I highly suggest you to go through all those topics if you are interested, and if you want to revise all those chapters, then we are adding all those things in detail, so any beginner from advanced level, anyone would be able to go through this course easily without any hesitation. Now without wasting any time, let's go towards learning Spring Boot. Now what is Spring Boot? Before understanding Spring Boot, we need to understand what is Spring Framework and why there was a need of a Spring Framework. When the Java was introduced, developers used to develop the application using the Java J2EE, that is the Enterprise Edition. They were using all the servlets and JSPs to create our application. Then on top of that, there were different frameworks created. There were frameworks like Struts, Liferay, Spring and many. And with all those, Spring is the most famous framework. Now why was Spring the most famous framework? Because Spring provides a lot of functionality and it provides a lot of different modules to work, and they can easily work with the different modules and we can create the applications easily. So suppose if I want to build the web application, I can use the Spring MVC module. If I want to work with the batch processing, I can use the Spring batch processing module, and there were many modules available which I can easily use and integrate those modules with the Spring framework. With that being said, there were a lot of configurations also required to work with Spring. So in the earlier days, Spring was configured using the XML configuration. So you had to add a lot of XML configuration to work with Springs. So if you added the base Spring core module in your project, so for that you had to do some configuration. On top of that, if you are adding Spring Web or Spring MVC dependencies, then for that, using those modules, you have to do some configurations in the XML file. Now, if you are using any ORM framework like Hibernate, iBuddies or anything, so for that you had to do some configurations. So that means for each and everything, you had to do some configurations to work seamlessly. Now, though Spring framework provides a lot of functionality, there was a drawback about a lot of configuration, because though Spring framework was also known as frameworks of frameworks because it allows you to integrate all the different frameworks within the Spring. That comes with the drawback of the multiple configurations. There are a lot of configurations. Now, to solve that problem, Spring developers decide to build a framework around it and to minimize the configuration from the developer side. So for that reason, Spring Boot framework was introduced. Now, if I define you in the simple words, Spring Boot is the abstraction layer on top of the Spring framework. So Spring Boot is built on top of the Spring framework, plus it has all the different configuration added to it. That means all the auto configuration is been added to the Spring framework. So whenever you have to use any frameworks or any modules of Spring, all those basic configurations are added in your project by default. You don't have to add anything. Only if you are doing some changes in the configuration, at that time you can add those configurations very easily. So you can see that a lot of burden from the developer's shoulders was put off. and all those configurations and all those functionalities and everything was by default provided to the developer. So developer can only focus on their actual business logics. So this is why Spring Boot is widely used in the industry, and it is really easy to develop application in the Spring Boot. Now, whenever we talk about any frameworks or particularly with Spring, we talk about dependency injection. Now, what is dependency injection? Let's see that. Now, consider you have a class student. So let me just define here. I have a class student, and in this class student, I have few fields. Suppose first name, last name, and email ID. Okay, there are few fields with this student. Now, whenever we want to use this particular class, what we do is we create the objects. So what we do by default is we create student s equals to new student. So this is how generally we create the object in Java, right? Now what we are doing is we as a developer are creating the objects here. So that means I have a complete control on creating the objects. Now within this student, I need the object of a subject. So I am defining the subjects here. Now this subject is a class. Okay, so let me just define the class subject here. And within this subject class, there are different things like name of the subject and the class teacher of that particular subject. And there are other details available within this particular subject class. Now you can see that as the subject is a class that is the dependent, right, in the student. So student is dependent on the subject class. That means whenever I want to use the student class, I need the object of a subject, because within the student I need to define that what are the different subjects of a particular student. So what I had to do is generally I had to create the subject class, and then that particular object I need to pass to the student. Now you can see that this everything is done by manually by me as a developer, but to create all those particular objects by a developer, by a user, is not ideal, right? Because there are a lot of dependencies available, and there might be chances as well that user is creating a lot of unnecessary objects as well, and the garbage collection is not proper, and there might be a lot of scenarios. So what Spring suggests is, Spring suggests to use the inversion of control, which means to give the control to the framework itself rather than taking the control to your own. So what IOC defines is inversion of control. That means giving control back to the framework. Now to implement this, we use the dependency injection pattern. Now dependency injection pattern allows us to use the IOC where all of the dependencies are being handled by the Spring framework itself. Now whenever we define all the classes in the Spring framework, we define all those particular classes as a bean. So we define all those different beans, and whenever the Spring application starts, it creates the factory of all those beans. It has a bean factory, and all those beans are created and stored in a container. So suppose I have 10 beans available, all those 10 beans are created and stored in the container. Now if any of the beans is dependent on the another bean, Spring framework takes the responsibility to inject all those beans wherever it is necessary based on the different scopes defined in the Spring framework. So you can see that rather than creating the objects by a user, by a developer itself, Spring takes care of all those particular things. Rather than developer worrying about creating the objects, doing the garbage collections, and unnecessarily creating all those different objects, Spring's framework tells that, hold on, I will do everything for you. You just define that what you need. You need 10 classes. Don't worry, define those 10 classes, define the different scopes for that. I will take care of each and everything. So that dependency injection is taken care by the Spring framework, and we have to define like which particular bean is required where. We will see each and everything in the code when we are doing the examples, but this is a general idea what dependency injection is. Now as we have gone through what is Spring Boot and what is dependency injection, let's try to create a simple Spring Boot project, and from there we will go towards the different topics. So let's create a Spring Boot project. Now to create a Spring Boot project, there are different ways available. By default, Spring developers has provided us with the Spring Initializr tool with which we can create the Spring Boot projects very easily. There is a Spring Boot CLI tool also available, and within your IDEs of your choice, you can also create your Spring Boot project. I will show you here with the Spring Initializr. So whatever IDE you are using, you should be able to create the project and open that project in the favorite IDE. So open your browser and go to Spring Initializr. So go to start.spring.io. Okay. So you can see that this is the tool available to create your Spring Boot project. And here you can see that there are different options available. So first of all, you can see that what type of project you want to build. You want to build a Maven project or you want to build a Gradle project. Both of these are project management tool. You can use any one. We are going to use Maven in this entire course. So we are going ahead with the Maven project selection here. But if you are familiar with the Gradle, you can also go ahead with the Gradle. As Maven is widely used in the industry for Spring Boot application, we are going ahead with the Maven project. So here the project selection is Maven here. Then you have to select the language, in which language you want to create the project. There are three options available: Java, Groovy and Kotlin. We will go ahead with the Java, but if you are familiar with Kotlin and Groovy, you can go ahead with that as well. Then here you can see that you will get the option for choosing the Spring Boot version. The current stable version is 2.7.2, so we are going to use this version. But whichever version you want, you can use this particular versions from here. You can select any versions from here. And then you can see there is a project metadata. This is the artifact information of your project. So for each and every project, you need to define three things. That is the group, artifact and the version information. So with these three details, your project would be unique in the entire repository. So ideally the group name is given as the domain name. So my domain name is dailycodebuffer.com. So I'll give that com.dailycodebuffer. Okay, and generally it is given in the reverse order. So I have given com.dailycodebuffer, and then you have to give the name of the artifact, what name your application would be. So I am just giving that Spring Boot demo. Okay, simple. And then the name of the application and then the description, and then you have to give the package name. So package name I'm giving as Spring Boot demo. Simple. Okay, and then you can see that you have to choose the packaging. So either you want to package as a jar or you want to package as a var. If you want to create as a standalone application where you can directly run your application, you go ahead with the jar file, and it will also have the embedded server in it. We will talk about embedded server later, but when you're choosing the jar packaging, the embedded server will come together. And if you want to deploy your application to any another server manually, then you can go ahead with the var application, var packaging type. Then you can see that Java version. So which particular Java version that you want to select. In my machine, Java 11 is installed, so I will go ahead and select Java 11. Then if you come here, you can see that there is a dependency sections available. So if you click here, you can see there are a lot of dependencies available that you can add in your Maven project. So you can see that Spring Native, Spring Boot, DevTools, Lombok, Spring Configuration Processor. There are a lot of different modules available, different dependencies. Whatever dependencies you add, that dependency will be added in the pom.xml file. That is the Maven configuration file for your project. Okay. So what I'll do, as we have to create the web application, I will select the Spring Web here. You can also add multiple dependencies here. Then what you can do, there are three options available: to generate your project, to explore your project, and to share the URL. So if you click on share, the URL will be created, and whoever is using that particular URL, all those fields and dependencies will be auto-populated for them. And if you click on explore, you can explore the projects and you can explore the project structure over here. You can see that there is a .mvn folder available. That is the Maven wrapper. That is mvnw and mvnw command. So if Maven is not installed in your system as well, you would be able to easily work with this project. Then you can see that pom.xml file is there. This is the main configuration file of your project, and it is the Maven configuration. That is also called as project object model. So here you will see all those configurations of your project. As you can see, all those informations are added. What was the group ID, artifact ID, version, and the relative path. Okay, and you can see that this was all about the Spring Boot starter parent. Always Spring Boot project will be having a parent, and the group ID, artifact and version, this is something that we gave, and the name of the project. And here we have added the dependency, that was this dependency, and Spring Boot starter test. This is the by default dependency added, and there is a source folder also available. Okay, you can see all those information here, and you can click on the download button to generate your project. And you can see that the project is generated. Now we can go ahead and use this particular project and open this project in our favorite IDE. So let's do that. So here you can see that this is a project that I have downloaded. Now let's unzip this. Now you can see that this is the unzip folder. Now you can open this particular folder in your favorite IDE. You can either use Eclipse, you can use Spring Tool Suite, that is STS, you can use IntelliJ IDEA, or you can use VS Code as well. Whatever you are familiar with, you can use that. In this particular course, we are using the IntelliJ IDEA. If you want to install the IntelliJ IDEA on your machine, you can go towards the browser and search for IntelliJ IDEA and go towards the community version. So install the community version here of this IntelliJ IDEA and you should be good to learn anything. You should be good to use this software. I would highly recommend using IntelliJ IDEA because in this course we are going to use that, and if there is any issue we should be able to help to solve any of the issues here. But if you're not comfortable with, you can go ahead and use any of your IDEs. So once you have downloaded it, what we will do is we will open the IntelliJ IDEA here and we will open the project. We'll click on open project here and we will select the project. We'll go to the documents, Springboot Microservices project, Springboot demo, and this is the project that we need to open. So we'll open the project here. We'll trust it. And you can see that the project is open. For the first time, it will take some time to download all the dependencies in your machine. So wait for a couple of minutes to complete all the processes. Once everything is done, you can see that your project structure will be this way. You can see that your project structure is there, your pom.xml file would be there, and your src directory would be there. Okay. If you open your pom.xml file, this is your pom.xml file and all the configurations are here for your Maven project. And in the src directory, you can see there is two folders, main and test. Test will include all your test cases, that is JUnit, and your main is your main application code. If you open main, there are two things, that is Java files and the resources files. In the resources file, you can see there is an application.properties. So all the configuration, all the settings that you need to do, all the properties you will be adding in the application.properties, and your all Java classes you will be adding in the Java folder. By default, one application file will be there created and there will be one main method, so we can run our application. This is the entire application, and if I want to run this application, I can just run this from this play button here, and if you are in the Eclipse, you can do right click and run as Java application. So I'll just start my application here, and you can see that your application is started, your application is deployed to the default Tomcat server. That embedded server comes with the Spring Boot. If you go here, you can see the logs as well, that your Spring Boot application is using Java 11. Okay, the Tomcat is initialized on port number 8080, so it's using 8080 as the default port, and your application is started. So if I go to the browser and if I do localhost 8080, you can see that your application is working fine. There is an error shown here because there is no handler mapping configured yet. Okay, so this is how you should be able to create a project using Spring Initializr and open in your IDE, and you should be able to run your project. Now as you have configured your Spring Boot application and started your Spring Boot application, let's create a basic controller and serve that request. So what we will do is we will go to our IntelliJ IDEA, and what we will do is we are going to create the hello controller. Okay, so basically what we are doing is we are creating one REST endpoint so we can serve the request. So it's very easy to do that. So what we will do is we are going to create a package so we have a proper structure. Ideally, whatever we will do in our Java application, we are going to create different packages for the different types of classes that we are going to create. As we are going to create a controller here to handle the HTTP request, we are going to create a controller package, and in that controller package we are going to create a class. So let me just create a Java package here, and that says controller. Okay, the package is created, and within this package let me create a Java class that says home controller. Okay, you can see that simple class is created. Now all the configurations in Spring Boot we will do mostly using the annotations. So we'll define the annotations, and based on those annotations Spring Boot will react to it and the functionalities will be added for that class. So you can see that this is a simple class created. Now what I want this particular class to do is I want this particular class to behave as a controller. That means to serve the different requests for me. Okay, so for that what I'll do, I will use a annotation that is @controller. You can see that this controller annotation is from the org.springframework.stereotype annotations .stereotype.controller. So you can see that I have just added the @controller here. That means now this class home controller will be behaved as a controller. Now one more thing. Now this home controller, whatever the methods that I'm going to create here, I want to create all those as the REST endpoints. That means I want to send the data in the response body format. Okay, either would be JSON or XML or anything. I want to return the data. I don't want to create the MVC pattern where I will be passing the JSPs or the index files. So what I will do, I will annotate this with @response body. Now what we have done till now is we told the Spring that my home controller class, that whatever I've created, that should behave as a controller, plus it should also behave in such a way that it should return the data in the response body itself. Okay, it should not go to search for any views configured. Okay, we are not configuring any views, we just want to send the data back in the response body format. This is what I have defined here. Let's define the endpoint. So whenever I hit any endpoint, I want that endpoint to reach here, and whatever the method is there, it should reach that method, and whatever the steps that I have written in that method, all those things should be executed and the response should be sent back. This is something that I want. So what I'll do, I will define a method, public method. What I want in return is a string. So I'm defining string here, and the name of the method says that is home. Okay, this is a simple thing. Now I want to return hello world. Okay, you can see that simple thing that I have defined here. Now I want this method to be attached to any of the endpoints, okay, to any of the resources. So what I'll do, I will configure that way. So I'll define the annotation to do that. The annotation is @request mapping. Okay, so all the requests that comes here in this home controller, I am mapping that request to come here. Now which request should come here? So I need to give the path of a request. Okay, so I'm defining that all the request with a slash. Okay, that means my home path should come here. If I do ABC here, that means all the requests with /ABC will come here. Okay, that's a simple thing I'm defining. So let me just put it the slash only. Now what I will do is I will just restart my application. Currently, if you see that if I still run, nothing happens, right? So what I'll do, I will restart my application. You can see that my application is restarted. I'll go to the browser again and I will refresh the page. And you can see that I am getting hello world here, right? So you can see that I have mapped the slash request, that is the home request, to this controller method, that is public string home, and it is returning the string here. Very simple thing that we have done here. So we just created a controller, we created a method. That method will have a request mapping, and whatever the request will come to the given path, this method will serve that request. That's a simple thing that we have defined, and this is the basics of each and everything that we are going to do in the entire course. We are going to create a lot of different REST APIs, and we are going to call another REST APIs from one of the APIs and vice versa. Now you can see that whatever we did was right. With just 5 to 6 lines of code, we were able to create our entire application. We were able to deploy each and everything in the embedded server, and we were also able to map a particular request as well, and we were able to send the response data back as well. You can see that we did a lot of things, but we did only 5 lines of code. Rest everything was handled by the Springboot itself. And if you go towards the pom.xml file as well, okay, here you can see that there is only 2 dependency it is added. But ideally we only added one, that is the Spring Starter web dependency. This one was by default added. Okay, so you can see that everything here, you can see it has something called starter. You can see that Springboot starter parent. You can see that Springboot starter web. You can see Springboot starter test. So what is this starter? So what Springboot does is Springboot bundles all the required dependency into one bundle, and it's called as a starter. So if you're manually creating anything, suppose if you're creating an application and in that application you need 10 dependencies, you will go ahead and do all those 10 dependencies. But the same 10 dependencies you want to use in any other project as well, then you will go ahead there as well and you will add all those 10 dependencies. In the third project, if you want to do, you will do the same things. You will go ahead and add those 10 dependencies. That means all those 10 dependencies are basic to create or to give you some sort of functionalities, right? So what Spring Boot does is it adds all those 10 dependencies into one of the starter. So that means whenever you use that starter dependency, it will have all those 10 dependencies configured for you. So you don't have to go ahead and add all those 10 dependencies. You just add that one dependency and you will have all those configurations, all those dependencies added to it. So here if I check for the Spring Boot starter web, we just added one dependency, and if you open this dependency, you will be able to see that this is the pom.xml file for the Spring Boot starter web, and here you will see all those different dependencies. You can see that it has the Spring Boot starter dependency, it has the Spring Boot starter JSON dependency, Spring Boot starter Tomcat dependency, Spring Web framework is added, Spring Web MVC is added. If it was not providing all those dependencies into a bundle format, into a starter package, which we would have to add a lot of dependencies. So this way it combines each and everything and give us. So if you go to the Spring Boot starter Tomcat, this is also a starter dependency bundled into another starter dependency. So if you go ahead and see this, here also it will be having different dependencies, right? So you can see that it has a Jakarta annotation API, Tomcat embed core, Tomcat embed EL. So you can see that there are a lot of dependencies and there are a lot of dependencies nested as well. So to minimize all these complexities, Spring Boot provides the different starters for us. So whatever the functionalities we want, we will just add the starters for that, and all the dependencies will be added in our project. So suppose if you want to work with the Hibernate, if you want to work with the JPA, you just add the starters of the JPA and you're good to go. If you want to work with the Redis, you just add the starters for the Redis and you are good to go. So this way there are a lot of starters available and you can just add those starters and you have all the auto configurations and everything added in your project. You don't have to go ahead and search all the different dependencies and everything. So this is how Spring Boot starters help us in minimizing the complexity and minimizing our code as well. Now let's understand how Spring Boot works. Now whenever you are creating the Spring Boot project, and we saw many times as well when we are creating the Spring Boot project, everything is automatically done, everything works like a magic, you don't have to do anything. But actually it's not magic. Everything is a code, everything is a programmatically written code, and all those things are added programmatically based on the different configurations that you add in your project. Now you may say, what configurations? I didn't add anything. But yeah, you would be adding something, and based on that, the configuration will take place. So let's see how the Spring Boot works internally. So whenever you're creating a Spring Boot project, it has the spring.factories added to the meta.inf folder, and all the configuration, all the jar files required are mentioned there. So whenever you add any properties or any configuration and it matches with the Spring factories, it tries to add that configuration to it. So based on the different configurations that you add, or based on the different dependencies that you add, the different configuration takes place internally. So if I show you, if you go to the external libraries here, and if you go to the auto configure, okay, and if you open here in the meta.inf folder, you can see that there is a spring.factories. So if you open this, you can see that all those configurations are added here. Now if I open one of the class, okay, I'm just opening one of the class, that is JPA repositories auto configuration. Now you can see that here there are different annotations available. Okay, now based on all these annotations, all the configuration takes place. So suppose if you are creating a Spring Boot project, and in that Spring Boot project you have just added the dependency of a web, nothing else, then only Spring Web will be added in your project. That configuration only will be added in your project, nothing else will be added. And if you want to work with the JPA, then you need to add the dependency of the JPA, and you need to give some properties to make sure that the configuration will work. So all those things how Spring Boot will know, right? So you can see Spring Boot will know all those things based on the annotations provided here. So this particular class JPA repositories auto configuration is to configure the JPA, whatever you have added, to configure your application to connect with your database. Now this will only work when it will fulfill all these conditions. You can see that it has a condition that conditional on bean, that is data source.class. So that means it should have the bean data source.class available in the bean factory. You can see there is a condition on conditional on class. So it should find the JPA repository.class in the class path, then only it will add the configuration. That is conditional on missing bean. It should not be having the missing beans. Okay, condition on property, it should have these properties available. So you need to define the spring.data.jpa.repositories. Okay, so when all these conditions are met, the auto configuration will happen, and any of the things are missing, you will get the error. So we'll see that as well when we are implementing the JPA. I will show you that how you will get the errors when you have not configured everything properly. So whatever the minimum things it needs, if you give those minimum things, then it will auto configure everything for you. Otherwise it won't configure, it will throw that these are the things missing. So all these things it will get to know from all these conditional classes and conditional annotations provided here. For all the different configurations, everything is defined this way only, and based on this the configuration will happen. So there is no magic. All these are conditional beans and conditional implementations. Everything is programmatically added to your project. Now this is something how the different auto configurations and how the different dependencies are added in your project. But how about running your application, how it works? So for that, let's see. If you go to the, let me close each and everything, and if you go to the Spring Boot application, okay, this is something that is very important annotation, that is Spring Boot application, and there is a method that is spring application.run. These two things help you to create your Spring Boot application. Now what it will do is, if you open this Spring Boot application, you can see that it ideally does main three things over here. So whatever the configurations are added in your project, load those configurations first, then do the auto configuration for all those configurations, and whatever the extra beans or components or anything that you have added, load all those things as well. So this is the task of this annotation. So you can see that first of all it will do Spring Boot configuration. So all those configurations have been added. So if I open this, you can see that it will check for all the @ configurations. So any class annotated with @ configuration is been used for configuration purposes in the Spring Boot. So once you have all those configurations, it will do the auto configurations. So enable auto configuration annotation is used to do all the auto configurations for all the dependencies and all the different configurations been added in our project. So if you open this, you can see that it will do auto configuration package, and you can see that it will import this class, and all those configurations are there. You can use all those things. And if you want to exclude any particular configurations, you can exclude. You can see that there is a property available, exclude and exclude name. So that means if you want to exclude anything, you can provide in the exclude annotations. So that means you have added the dependency of JPA, but you don't want the auto configuration of the JPA. You want to do everything manually. You can go ahead and do that. You just need to exclude the auto configuration and do everything manually by adding the different configurations, adding the different class, and annotating with @ configuration. So that's how generally it would be. So you can see everything is done for you by default with this one annotation. But if you want to exclude and do manually, you have the option to do that. Now once everything is loaded, your run method will run. Okay, and this run method will help you to start your application. So if you go towards this run method, if you open this run method, and let me go to this run method where we pass each and everything. Okay, so this is the run method that is going to run, and it will return the configurable application context. So at the end, it will return the application context which is configurable, and it will start your application. And you can see it is taking the different variable arguments here. So you can see that this method, first thing what it will do is it will bootstrap the application context. You can see there is a method create bootstrap context. So it will first create the application context for you. So whatever the context it has to create, right, by adding all the different beans into the IOC container and everything will be added, and your context will be created. And you can see that after that there are different things. You can see configure headless properties, all the different configurations will be added. And if there are any listeners added in your application, it will get all those listeners and attach to your application. And you can see after that it will take the arguments. So if there are any arguments added, right, whenever you are starting your application, you will be adding the different arguments. So if there are any arguments, all those arguments will be added, collected, and will be added in your application context into your configuration. And once everything is added, it will refresh your context to get everything into the updated context. And also it will do one thing is, whenever it's creating the application context for you, it will also check what type of context it is. So if you are adding the web dependency in your application, that means it will end up creating the web application context, right? Because you are creating the web application, and web application context needs to be created, and that needs to be deployed in your embedded server as well. So all those steps are added. If you are not creating a web application, you are just creating the terminal application, those type of contexts will be added. So there are different types of contexts available based on the dependencies that you have added and the configuration that you have added. The different context type will be created and will be attached in your application. And after that, if it's a web application, it will also create the Tomcat embedded servlet container. That container will be created and your context will be attached to that container. So that means your context can run on the embedded server provided. We will talk more about the embedded server later, but whatever the embedded server has been configured for your application, that particular servlet container will be used to create your application, and the context will be attached to it. So you can see that it is nothing magic. It is based on all the configurations and dependencies we add. Whatever the dependencies that we are adding here from the Spring dot factories, it will do the configuration, and based on the classes added, based on the configurations added in the application dot properties, all those configuration, all those auto configuration will happen in a project. And based on this @Springboot application annotation, it will first try to get all the configurations, it will enable all those configurations, and it will scan for all the packages to get all the different beans available, and everything will be ready for you to use in the IOC container. Okay, as we talked about IOC container earlier, every beans will be there in the IOC container for you to use. And whenever the run method is called, all those beans are being used to create your context. Your context is defined based on the different dependencies, either it's a web context or a normal application context or anything. And based on that, whatever the embedded server is defined for your application, that embedded server container will be used to attach the context to that container to start your application. Everything easily defined, everything is defined within the run method itself. You can go through that easily and you will be able to understand each and everything. So there is no magic at all. Now let's talk about the embedded servers in the Spring Boot application. Now ideally, whenever you were creating the Java application or the Spring application, what you do is you create your application. Okay, and that application will be packaged in the WAR file, and this WAR file you will go ahead and deploy to the server. Okay, that's the generally flow you would be doing, and this server would be Tomcat server, WebLogic server, JBoss server, anything. Okay, there are different servers available. You will go ahead and deploy this WAR file to any of the servers. So that means there are a lot of configuration that you have to do for your application as well and for your server as well. But with Spring Boot, how about application plus server all together contained in a single jar file, right? And you just run this jar file. You don't have to worry about deploying to any of the server. It has the server inbuilt to it. Now, there are three types of server available as the embedded server in the Spring Boot application. That is Tomcat, Jetty, and Undertow. And if you go towards the reactive Spring Boot application, there are different servers for that as well available, like Netty and all. But let's keep those things aside. Whenever you are creating the simple Spring Boot application, these are the servers that are used. And Tomcat is the by default choice and by default option available. Okay, so if you go here, in your application, you have just added the Spring Web dependency, that is the Spring Boot Starter Web. Only one dependency we have added till now. Okay, and whenever I will open this dependency, if you scroll down here, you can see that there is a Spring Boot Starter Tomcat dependency available. So whenever I'm adding the Spring Web dependency, Spring Boot Starter Tomcat is the default option I'm getting. So that means my application will run on the Tomcat server whenever I'm starting my application. So if I start this application, let me just restart the application. And if I scroll here, you can see that my Tomcat is the container here, right? and you will see everywhere that my Tomcat has been started. It's a Tomcat web server. Okay, so it's by default Tomcat option and everything works fine. Everything is completely fine. Everything is okay. But what about using Jetty, right? Why can't I use Jetty? Let's see how we can use Jetty. So what I have to do is, as my Spring Boot application already has the Tomcat in it, I have to remove Tomcat first and then add the Jetty to it, right? Then only it will able to understand that I need to run my application on the Jetty. If I keep both Jetty and Tomcat both together, then it will get confused what to use, right? So that means I need to remove Tomcat and add the Jetty. So that's something that we have to do. So what I'll do, as we already saw that Tomcat was inside the Spring Starter web, right? So this is the dependency, and inside this dependency, Tomcat was there. So what I can do, I can go ahead and exclude the dependency. So what I'll do, I will add the exclusion tags here. I will add the exclusion tags, and in the exclusion tags, I will add exclude. Okay, and here I will add Spring Boot Starter Tomcat. Okay, Spring Boot Starter Tomcat is the dependency, is the artifact that I want to remove. I'll use that, and I will use the group org.springframework.boot. Okay, you can see that I have excluded the Tomcat dependency. Until now my application is started, right? If I go here to my browser and if I run this, it's working. But the moment I will restart my application, you can see that my application still runs, right? Because I have not refreshed the Maven dependency. So let me just refresh, load the Maven changes. Okay, you can see that the application is loaded. Now Maven knows that we need to remove the Tomcat dependency from the Spring Web dependency. Let me restart the application. And now you can see that your application worked, but it didn't deploy. You can see that no logs are available that it deployed into Tomcat or the Tomcat is running on port, any of the port number, right? Nothing is there. And if you go here, nothing is working, right? Because your application is fine, your application is working, but there is no embedded server now. We had excluded it. Now we can go ahead and add Jetty to it. So what I will do, I will add the dependency. So after the dependency of the web, I can add the dependency. I've added the dependency and I'll add Spring Boot Starter Jetty. Okay, and it's from the org springframework.boot. And I will refresh my Maven settings, my Maven project. You can see that it's syncing, it's completed. Now if I restart my application, let me just restart it. And you can see that the application is started, and you can see that now it's a Jetty web server and the application is deployed on the Jetty on the same port 8080. Now if I go back and if I run my application, you can see that my application is running fine. So you can see that in just simple 2 steps, we just change our server, right? How easy it is. Now you might also say like, how about changing the configurations of these servers that we are using? So we can do all those configurations in the application.properties. Suppose I want to change the port number. So I will just go here and I will just do server.port. Spelling is wrong. Server.port. You can see the server.port. I'll just change to 8081. Okay, simple. And if I rerun the application, and if you see the logs, you can see that now your Jetty has started on port 8081. Right? If I go back now and if I run the application, it won't work on 8080 because I should work on 8081. You can see that now it's working on port 8081. Now you can see that we added this exclusion manually, but sometimes we might not know that what are the exclusion that we need to do or what particular dependencies we need to remove. So 2 ways I can suggest you is go through this particular artifacts, and from here you will be able to understand what is available. Here you can see that from this particular Spring Boot Starter Tomcat, we were able to understand that this is something that we don't need and we need to remove. But there might be complex scenarios when we are working with the complex projects. There are multiple dependencies available. There might be conflicting dependencies as well available. So to handle all those and to rectify all those scenarios, what I would suggest is a simple way. There is a plugin available in the IntelliJ IDEA, that is, let me go to the plugin section, and The plugin name is Maven Helper. Okay, just install this plugin and restart your IntelliJ IDEA, and you will be able to see all those dependencies in your Maven file. So once you have installed this plugin, that is Maven Helper, you will get the extra tab over here, that is Dependency Analyzer. Okay, so currently you can see that in the Spring Starter web, we had added the exclusion by default manually. Let me just remove it for now, and let me just refresh this. Okay, and then what we will do is, let's go to the Dependency Analyzer here. Let's refresh the UI. Okay, and here if I search for Tomcat, if I select all dependencies as list here, you can see that I'm getting Tomcat embedded core server here, and you can see this is from the Springboot starter Tomcat. Okay, it's from here as well, and it's from the here WebSocket as well. So what I want is, I want to remove this, right? So what I can do, I can click here and jump to the left tree. It will show me here that this is something that is part of the Springboot starter web. Right click on it and exclude. Once you add this, and if you go to the text, and if you scroll up, you can see that the exclusion is added automatically. Okay, you don't have to add everything. So this way you can use this Dependency Analyzer plugin to handle your dependencies. Now let's talk about the Springboot actuators. Springboot actuators are nothing but a tool that allows us to monitor our Springboot application. So whatever happens in our application, that all things we can handle using the actuator. So actuator gives us different endpoints to monitor our application. So to add the Springboot actuator, we need to add the Springboot actuator dependency in our project. So what we will do, we will go to our browser, and I will go to start.spring.io, Spring Initializr. I will go to the dependencies, and I will add the actuator dependency here. Okay, Springboot actuator. You can see that it supposes built-in or custom endpoints that let you monitor and manage your application, such as application health, metrics, sessions, etc. Everything we can handle using the Springboot actuator. So if I just add this dependency, and if I do control space explore, I can get the dependency here, right? So what I'll do, I will just take this dependency, I'll copy this, and I will add in my project. So I will go to the pom.xml file, and in the dependency, after dependency, here I will add the dependency. Okay, this is a Springboot actuator dependency. You can see that it's simple. We just added a dependency. Now I'll just restart my application, and if I scroll here, you will be able to see that exposing one endpoints beneath base path / actuator. Okay, so you can see that there are few endpoints added in the /actuator endpoint. So if I go to my browser, and if I do /actuator, you can see that these are the endpoints. Let me just zoom out. You can see that you will get this information. So that means your actuator has been added in your project, and you can check the health. So currently there are 3 endpoints. This is the main endpoint, this is the actuator /health, and actuator /health /path. If I go to this, you can see that I'm getting the status as application is up. Okay, now this is just a basic information available. This is the default thing available, but there are a lot of different configurations that you can add to modify that different endpoints for you. So suppose if you want to get all the beans registered, you can do the configuration. You can enable all those endpoints, and those endpoints will be visible for you. So for the security reasons, only one endpoint is being exposed directly just to check the application health. Rest of the endpoints are secured and disabled by default. If you want to enable, you can go ahead and enable those endpoints based on the configurations, based on the security. You need to add the security so that no one would be able to see those endpoints. By default, the status is fine because there is nothing that has been exposing from your application for this. It just your application is healthy or not. So this way you can add the actuator. There are different configurations available. You can go through the documentation and add the configuration. It's fairly simple. Now let's talk about Springboot DevTools. As you have seen that we have gone through a lot of things available, and every time we are doing some changes, we are restarting our application, right? This is not feasible when you are doing a lot of changes. So Spring Boot DevTools gives us the tools that will help us in developing our applications. So for that, we need to add the developer tools. The first important thing is live reload functionality. It will allow us to do all the changes, like whenever we will do the changes, it will automatically detect all those changes and it will build the project and deploy the project. That's the basic thing that we are going to use from the Spring Boot DevTools. Again, what we will do is we will go to the Initializr start.spring.io. I will go here, I will add the dependency as the DevTools. You can see Spring Boot DevTools provides fast application restarts, live reload and configuration for enhanced development experience. This is something that I want. I will select this. I will go to the browse explore section and I will copy this dependency. This is the dependency that I need. I'll copy this, go to my Spring Boot application, go to the pom.xml file and I will add this dependency. You can see that dependency is added and I will do the load Maven changes. Now after this, if you're working with Eclipse, STS or VS Code, you are good to go. All those live changes will be reflected directly. But in IntelliJ IDEA, you have to do some configurations. So if you are on Mac, go to IntelliJ IDEA and preferences. But if you are on Windows, go to file settings, open this and go to build and execution, deployment, go to compiler and just select this build project automatically. After that, what you have to do is once this is done, go to advanced settings and enable this allow automake to start even if deployed application is currently running. Just enable these two settings and click on apply and OK. So now whenever you will do any changes within 5 to 10 seconds, it will reload each and everything and everything will be deployed for you. Okay, so you don't have to restart the application now and then. So this is about Spring Boot DevTools in Spring Boot and it will help to reduce the overhead burden to restart your applications. Now in this section, we are going to learn about the web services. We are going to learn what is web services, how web services work and what is RESTful web services, because we are going to develop a lot of RESTful web services in this entire course. So we need to have the basic understanding about what is a web services and the different aspects of it. So let's check this out. What is a web service? If I give you an example like any social media application, right? Are those applications directly a web service? It's difficult to say. Ideally, if I had to define web services in a wide general form, it would be like any services that I can access over the network. It's on the web, it's on the network, so it should be ideally be able to access from the network. The other thing is it is a service, so any application would be able to access those servers. That's a too broad thing that I'm able to think about when it comes to web services. But if I show you in the more detailed manner, if application 1 is able to use the application 2, okay, over the web, okay, this is web. My drawing is bad, so please don't mind. Okay, if any one application is able to access another application over web, it's a web service. It's simple, right? Now, as I took the example of a social media, right? Suppose let's take the example of a Facebook, Instagram, or Twitter, right? Anything. Are those application web services? Ideally, I can say no, but internally it might be. If those application, I am as a user, I am directly using those applications. So if a user is interacting with those applications, I cannot tell those as a web services. But if one application is accessing another application, suppose there is another application called the analytics, right? Analytics of the social media. Okay, if any of the post or anything, how the interaction is, how the impression is, and everything has been calculated, right, based on the data provided, right? So that means there are some web services enabled here which an analytics application can use those endpoints can use those services exposed by this application, and it can generate some data. That's what something I can call it as a web services. If we take the example of a Twitter, right? So directly we can access Twitter right from the Twitter application. But there are a lot of other third-party applications also available that can use Twitter, and we can use those applications to tweet, read tweets and everything. So that means it's not a different application, it's a Twitter itself. So what Twitter is doing is Twitter is giving web services over the HTTP protocol over the web, right? So that means over the HTTP protocol to access or to be available by the other application to use. So there are multiple application A, B, C, D. All these application can access these web services and can use the data from this web services. So I can say that's the general idea about the web services. Now you don't have to get overcomplicated about all these things. You just need to understand like this is what a web service would be. Now there are different types of web services available. That is a REST web service and a SOAP web service. Okay, we will be mainly concentrating on the REST web services. Now let's talk about how web services work. So let's take the example here. Okay, how web service works. Now as we saw that web services is used to have the interaction between two applications. If there is application 1, right, and there is application 2, both this can interact with each other on web via web services. Okay, that means both are on the web and they both can interact with each other. Now how will they interact with each other? Okay, so ideally what will happen is application 1 and this is application 2. Now application 1 will send a request to the application 2 that I need some data or I need some processing to be done. Okay, and on return what application 2 will do is application 2 will process this request. It will get all the information that application 1 is requesting and it will do the processing and it will send the response back. Okay, this is the ideal or general flow for the requests and responses. So all the application 1 or any of the application, if application 2 has exposed the services, application 1 can use those services via the request. It will do the request like I need this data over a resource, over a URI. Okay, so a URI has been called for that particular request and application 2 will process those requests and it will send the response back. So that's how generally the web services will work with the help of requests and responses. Now all this particular thing will happen over a web on a particular protocol. So if I tell all this thing is happening over any one protocol. So in this case I am telling this is happening over the HTTP protocol. Okay, that all the requests and response has been handled for each and every application. Now how application 1 will get to know that what request I need to send and what response I'll be getting, and how application 2 will get to know that on what request, what response I need to send, right? So that is something that we need to take care of. We need to set up a contract for the services that we create for handling all these scenarios. So ideally whenever there is a web services in place, for any web services there are some things that needs to be defined. So the one thing is what is the request type. Okay, that means what request it will have or the request data. Okay, I can say okay, like it may be string, it may be XML, it may be JSON, anything. Okay, and what other thing would be like the type of data, like what type of data it is expecting and what type of data it is expecting back, either XML or JSON, anything. Okay, these are the standard formats used to pass the data. Okay, now the other thing is what would be the response object, okay, or the response data. What data needs to be sent back for a particular service when the request has been completed. Okay, and the next thing is the resource, or I can say URI. Okay, where we are going to call this service. So ideally like maybe the URL, okay, like localhost or www.dailycodebuffer.in, whatever, / suppose user is one of the URI, URL slash user slash 1 is one of the URI. So these are the different URIs can be defined, and based on all this data, based on this particular contract, web service is defined, and all the different application would be able to understand what data needs to be sent and what data needs to be requested. Okay, now all this thing, everything is we have defined here will happen based on the different HTTP methods. Now why I'm telling that everything will happen on the HTTP method, because we are using the RESTful web services. We are going to work with the RESTful web services. So for that, different methods are defined, like get method, post method, put method, delete method, and post, and options and patch, and there are different methods available. So based on these different methods, a URI, a resource is defined, and the operation will happen. So if I want to get the data, I can define a particular URI with a get method to get the data. If I want to create any data, I can define post. If I want to update, I can use the put. And if I want to delete, I can use the delete methods. So this is a general definition and the general idea, what are the things that defined and how the web services will work. Now let's talk about the RESTful web services. RESTful web services means representational state transfer. That is REST. That means a service can be representative based on the state and how the data transferred will happen. Okay, we will get to know about each and everything in detail. So what does it mean is, whenever we are creating a RESTful web services, as we talked about earlier, like what all the definition where we need to take care about, what is the contract that we need to take care about. So here if I consider there is a web service is created. Okay, there is a web service that is created. Okay, now web service is created. Now irrespective of any language or any technology or any framework, we should be able to access these web services based on REST. So that means it has to define some standards so anyone would be able to access it. It's not like only Java application can be able to access a Java web service, only the .NET application can be accessed the .NET web service. It's not like that. It's a representation of a service. It means everything is represented in a form and anyone would be able to use that. So if this service is defined like how the data it's need to be processed, either it is processed based on the JSON or XML. Okay, these are the two standard data formats used in exposing the services to send the data to and forth. Okay, what type of data it is, what is the resource, that means URI, okay, which URI we need to call, what is the HTTP method, okay, like get, put, post, or what it is, and what would be the request format, and what would be the response format. Okay, you can see that all these particular things are defined as a part of a contract in this web services. Okay, now everything is defined here and is available. Now either it is a Java application or a .NET application or a Go application or a Python application. Okay, whatever it is, they can go and call these services. It's that simple. Okay, anyone would be able to come here and whatever the contract is defined and whatever the definition is defined, based on that, anyone, any application developed in any of the language or framework is able to get the data from here, from this web services. Other than that, what it will define, whenever the resource is defined, like for each and everything, what we will define is what is the request. Like we will do the get operation, we will do the post operation, put operation, or whatever, anything is defined. For the request, like we will do the request this way. In return, we have to send the response back. So in return, what we will do is we will send the response data back. That will be body, like what data we need to send. Alongside, we will send the status messages. Like what is the status? We will send the different status codes like 200, 404, 201, 503. There are different HTTP status codes available, and all the status code define different things. Like 200 is okay, request is okay, 201 is request is created or the data is created, 404 is not found, the resource that you have defined is not found, and so on. So all these particular status codes are defined, and based on that the body is also defined. So whoever is calling this data based on the request that they have provided, they will get the data back in terms of the body, status, and the header information. Okay, all this data they will return back here. So all this particular application will get to know what happens. So if they got some body, right, in the JSON format, something, and the status is 200, they can get to know, okay, this request was successfully completed. If they got 404 and still they got some body, that means there was some error, and what was the error, that will be defined in the body itself. So you can see that most of the things are defined in a structured format, and a contract is defined for the web services. So what we are going to do is, whenever we are going to create the different APIs for our microservices, we are going to declare, or we are going to define a contract, and based on that contract, based on that definition, we are, or all the other services can call a particular web services. So whatever the definition that we have defined, we will share those definition, and based on that definition, other calling services can call those API. So you might have seen many places, like if whenever you are using the API, a contact information is shared, and based on that contact information you will get, or you will fetch all those APIs, all those REST services. So this is the general idea about what the RESTful web services would be, and how you can call those services, and what are the things that you need to define for a web services. We will see each and everything in detail when we are creating the web services, but this is a very basic idea, basic theory portion. If you didn't know, then if going through this would help. Now let's go ahead and create a RESTful web services. In the earlier videos we had already created one RESTful web services, so let's go there. We had created the home controller, and here we had defined a web services, right? We had defined a service, we had defined the endpoint, like whenever you will call your URI, that is localhost /8080, and the /, this is the method that will be invoked, and you will get the data in the string format, which is hello world. So if I check again, if I go to localhost 8080, I'll get the data. We had changed the port to 8081, so let me just change to 8081, and you will get the data that is hello world. Now you can see that it's very simple. And here what we had done was, we had defined the controller and the response body both together. That means this controller is responsible for handling the request mapping, that whatever I've defined, and it will send the data in the response body format. That means either in the XML or JSON. So that means rather than creating or using two annotation, that is @controller and @response body, I can directly define that this is a REST controller. That means I am creating the RESTful APIs. RESTful APIs means the same thing, that it will handle the resources, and it will send the data in the response body. It will send the data in the body alongside the headers and the status codes and everything. So we have just defined the REST controller rather than using response body and controller. And if you go to the REST controller, you will see the same thing, that @controller is defined and @response body is defined. Okay, so one less line of code. So now by seeing this, you can easily understand that this is a REST controller. That means this is going to handle all our RESTful web services, and this is my API. Now let's create a new endpoint where we can handle the objects. So currently you can see that we had only worked with a string, but now let's create the object, and let's see how we can send the objects back. So to create the object, what we can do is we have to create the object. So here what I will do is, I will create one class. I'll create a user class which will have some fields, and I will return that user. So for that, what I will do, I will create a model here. So I will create a package. So let me just create a package. I'll create a package that says model, and in this package I will create one class that is user. Okay, and here I will define some fields, that is private string ID, private string name, and private string email ID. You can see it's a simple thing, 3 fields I have defined. Now I will add the boilerplate code, that is the getters and setters, to make it as a POJO, right? So I'll just generate here getter setters for all. Okay, all the getter setters are done now. Now I will go back to my home controller and I will define a method to work with that user. So what I will do, I will create a method public, and what I want to return, I want to return an object. So I want to return a user object which I have defined. So I will use that user and I'll give the name of a method. You can give any name here. Make sure that you give a meaningful name. So I'm defining a user here, and here I can say I can create the object of a user. Okay, and I can define user dot set ID to 1, user dot set name to Shabir, and user dot set email ID to shabir@gmail.com. Okay, you can see that we have just set few of the fields here and the user object is created, and what my return type is user. So I will just do return user. Simple, right? Now I need to make sure that this method is able to handle those APIs, handle that request. So I need to make sure that I use the request mapping. Okay, so I need to map a particular request. Now what I will do is I will map a request with /user. So whenever you will do /user, you will be able to get this data. Okay, so this is simple. I have defined. If I go to run, you can see that using our DevTools, it is automatically recompiled and deployed. So if I go back, if I do /user, you can see that you are able to get the data back in the JSON format. You can see this is a JSON format and you have fields ID, name and email ID. Okay, now by default, whenever you will do such operation, it's a GET request, right? So you can see that this is the GET request I'm doing. If I check in the Postman as well, if I open Postman, Postman is a tool to test your REST API. So make sure that you install Postman as well. Okay, this is a Postman. What I'll do the new request and I will copy this URL. Okay, and I will add this URL. And here you can see that this is the URI that we have defined. And here we need to define the type of the HTTP method. You can see all those types are there. We are using the GET method. By default, it's a GET method. So we define this GET and we will do send. And you can see we are getting the record here. We are getting the same data here. And here you can see that we are getting a lot of other information as well, like 200 OK, which we defined, right? This is the HTTP status code. So if you go to the headers, you will get the header as well, like content type is the application JSON. So we are getting the data in the JSON format. Transfer encoding is there, date is there, key is there. All those values by default has been added by the Springboot. Now, as we saw, this is the GET method, but we have not defined that this is a GET method, right? We just defined this is a request mapping. So what it does is by default, it is always a GET mapping. So if you want to define other things, you can define such a way that whatever the user you define, you have to define in the value. Okay, so value is defined here, and then you need to define the type of a method. So suppose you are defining what is the method. Method is request method.get. Okay, this is same thing as earlier, but by default it's always a get method, so you don't have to specify. But if you are working with the another method, you can define. If you're working with the post, you can define post here and let it rerun here. You can see that it is working now. And if I go back and if I'm using get, and if I run again, if I go to body, you can see that method is not allowed, right? So that means if I do post here instead of get, because we have defined post, right? And if I do send, you can see that I'm getting the data, right? So post is allowed here. So this way you can define, but let me make sure it's a get because it was a get request. Now you can see that just to define it's a get request, I have added a lot of things, right? We had to define a value, and then we have to define a method as well. So rather than using this way, Spring Boot provides an efficient way to do that. Rather than defining @request mapping and defining the value of that request mapping and defining the method type, there are stereotype annotation that you can directly use. If it's a get mapping that I have to use, I can directly define @get mapping. Simple, and I can define the value, that is /user. You can see that your line of code is much easier to read now. If you want to define the post mapping rather than request method.get. You want to use request method.post. You can directly define @post mapping. Simple, and you can pass on the URL. And if you want to do put, you can define with put mapping. If you want to do delete mapping, you can define with the delete mapping. Okay, you can see how simple it is. Simple annotation you can directly use to define your method types. Let me just remove everything here. Now if you see here in the get mapping, it's the same thing. It is defined that request mapping equals to method equals to request method.get. So it's defined the same thing, but rather than doing everything by your own, already an annotation is defined, so you can directly define the annotation and you're good to go. So I will just comment this out and we will rerun our application. So let it reload the application. Application is reloaded, and if I go again here, check with the post, it should not work. And if I change back to get, it should work. You can see that it is working now. Now let's define path variables. Now what is path variable? Path variable is a path that you define in the URL. Suppose here if you define /user, /1, /2, anything, any values that you define, right? That is called a path variable. And path variables are always a mandatory thing. So whenever you need something to be defined in the URL, and based on that URL you need some different resources and some different configurations or different processing in your web services, at that time you can use path variable. Be sure that path variable you can only use when that particular information is a mandatory information. So suppose within this, right, user /1 I have defined here, and if I run this, it will not work because it will not found here. So that means whenever it's a mandatory field and if you want to get that information, define the path variable. So let's see how we can define a path variable. So what I'll do, I will go here and I will create a new method. Okay, this is a new method, public string, and I'll define path variable as a method name. Okay, and what I'm doing, I am defining a get mapping here. Simple. Okay, now what I want as a path variable, whenever I do slash, and if I do any ID, okay, you can see that I have added in the parenthesis here that whatever I defined here in the ID, that is something a dynamic field. So whenever that particular value is passed, that is a dynamic field and I want to process that. So whenever something is defined here, you need to take this as an input value in the method. So I can define Spring ID here. Okay, so this is something that I am taking as an input. Now how it will get to know that whatever that is defined, it needs to take as a path variable in the ID. So for that, there is an annotation that we need to define, that is @path variable. Okay, so whenever a URL is mapped and any value has been passed, that value will be mapped to the string of ID here using this @path variable annotation. Simple. And here I can define return. I'm simply returning whatever is passed. Return the path variable is plus ID. Okay, simple thing. Application is reloaded. So let me just go back, and if I do /user /1 and if I do send, it won't work because my get mapping is defined /ID. So if I just remove user here, okay, and if I do send, you can see that I'm getting the path variable is 1. If I pass ABC, then it will tell the path variable is ABC. So you can see that whatever you will define here, it will work. But suppose if I do ABC /XYZ and if I hit send, then you can see that it is not found because it is not available. Until here only we have defined. So if you want to define multiple path variables for a particular resource to be handled, you can do this way. /ID, and after slash you want any other path variable as well. So you can define ID2. And here you can define string ID2. And this is also a path variable, right? @path variable. So you can see that first ID, it will match with this ID and it will pass the value. Second ID2 will match your ID2 and it will be in the second path variable. And I can tell plus ID2. Okay, let the application restart now. Application is restarted now. If I go back again and if I run this, you can see that it is working. The path variable is ABC and XYZ. Okay. Now one more thing. Now you can see that the variable that we have defined, I don't like the variable. Okay, though it is whatever it is here. So what I want this as to be a name. Okay, whatever it is, I need this to be a name, but I have defined here as ID2. Okay, so what I can do is here in the path variable, I can define which particular variable that I need to take. I need to take ID2 from this. That means the second path variable and attached to in the name variable. Okay, that is something that we have defined. So the application is restarted. Let's check now. It should work as it is. You can see that it is working completely fine. So you can see that we saw how the path variable is defined, how the different ways we can define the path variables and how we can use the path variables. So whenever there is a mandatory data that you need to take, at that time we will define the path variables. Now in the next video we will see request parameters. Now in the previous video we saw about path variables and how to define path variables. In this video let's define the request mapping. Now when to use request mapping? Request mapping you can use when you have some of the data that needs to be taken but those are not mandatory. Okay, whenever the data is mandatory you take it using the path variable, but when the data is not mandatory, at the time you will take using the request parameters. So you can see path variable was declared with slash values, right? As the path / whatever the URL would be, like whatever the abc or xyz.com / whatever the parameters is there, whatever the path variable, that way you will define /parameter1, that is path variable 1 / path variable 2, that way. But request parameter will be defined with question mark, that is the query parameters. So after the URL it will be defined as a question mark, and then whatever the request parameters you define, those request parameters will be added. If those are multiple request parameters will be added, separated by the ampersand symbol. Okay, so let's define a method and let's see in working. So I need a method that returns string to handle the request params. So I'm just defining a method name request params. Okay, and I am attaching a request handler. So request mapping we need to attach. So we will do get mapping here, and what I will do is I will define request param as the URL. So localhost :8080 / request param we will call, and then whatever the request params are there we can define here. So suppose I need name. Okay, so if I need name I can define a variable string name, and I need that name from the request param. So I'll define request param here. Okay, and I will just return that. Return your name is name. Okay, let the application reload and we will check this. The application is reloaded now. Let's go to the browser, and what we will do, rather than 8081, whatever was defined, it was request param. So let me just copy this, and it was request param. Okay, and if I use this directly, you can see that it's an error. Okay, it's not working because there is a required request parameter here. So we need to define the request parameter. So we'll define request parameter with question mark. Okay, and then the name of the request parameter, that is name. So I'll define name equals to Shabir and enter. You can see that it is working completely fine, that I'm getting your name equals to Shabir. Okay, now let's define another request parameter. So let me define another request parameter, request param, and this is email ID. Okay, and here I'll define and email ID is email ID. Okay, simple code. Whatever I'm passing, I'm just returning back. Let the application restart, and let's go here and let's run the application. You can see that again we got the error because now we have defined two request parameters and I only passed one, so let's pass another. So to pass another, we will do ampersand symbol after the first parameter, and then we'll pass second. The second name is email ID. Email ID, the same name we have to give. Email ID equals to shabbir@gmail.com. And you can see that it is working completely fine. But now I don't want email ID as the parameter here. I want only email. So what I can do is either I can change this particular variable name here, or I can define here that my name should be email. Okay, let the application restart. Okay, application restarted. Now if I go and run the application again, it will again fail because we changed the email ID here. Right now it should be email. And if I run, you can see that it is completely working fine. Now what I need is, I don't want this email ID as a mandatory field. If I don't give email ID as well, it should work. It should not fail because these are non-mandatory fields. If its fields are available, then fine. If fields are not available, then that's okay, right? So what I can do is I can define comma required equals to false. Okay, that means if value is available, then fine. If value is not available, then fine. Then also it's completely fine. So if I go again here, if I run this, you can see that your name is Shabbir and email ID is null because email ID is not provided. If I provide email ID and email ID equals to shabbir@gmail.com, it will work because we just passed email ID. It should be email, right? Email. You can see that it is working completely fine. Now what I want is, I don't want to pass this email ID, but I don't want to be null as well. So if it's not anything, right? If we are not passing the data at that time, I want that default value to be set for that to be blank. Okay. Now let the application restart and we will check. Okay, we will check and let's run this again, and you can see that null is gone and we are getting a blank value. So this way you can see that we can handle the request parameters. You can see that we have gone through all those different types of parameter handling. We went through how we can handle with the different name, with the required, false, default values and everything. So this way we can handle the request parameters. So keep in mind, whenever you want the mandatory fields, mandatory values to be taken, use the path variable. Path variable will be always mandatory and the request parameter will not be mandatory. And if you want to handle that, you can always handle using the properties that is required false, and you can pass the default values whenever you want. So these are the different properties that you can use to create the request parameters and path variables. Now these are the most important and main things that we are going to use in our entire course. So if you are able to understand this and you are able to create the REST endpoints with the path variables, request parameters and the default values, you will be able to easily grab all those particular topics. So that's all in this video. I will see you in the next chapter. Now as we have understood the basics, let's create a CRUD application where we will use the employee as the object, and on that employee we will do some operation. So we will create the entity object for an employee, and with that employee we will try to create a CRUD application where we will try to save the employee, get all the employees, list down all the employees and list employees based on the ID, and we are going to delete that particular employee as well based on the ID. So for all this we will create the different APIs. So let's see how all these things will work. So as we are going to work with the employees particularly, so what we will do is we will create the employee resources. That means an employee controller, which means for all the requests to handle the employee will come to a particular controller, and that controller will be responsible to do all the operations for that. So within the employee controller there will be different methods, and all those different methods will handle all the different types of requests. And to handle that employee, to store all the data for that employee, we will create a model as well, a class, a Pojo class in the Java, in which we will have some properties, and that properties we can fill to store some data. So that's what we are going to do. As in the previous example, we had used the user model here to store some of the data. Now we will use the employee model. So let's go ahead and create one model. So what I'll do, I'll just create a new class in the model package itself, and I will name this as a employee. Okay, this is a simple Java class. Within this, let's add some fields. So what I'll do, I'll add some fields. Private string employee ID, private string, first name, private string, last name, private string, email ID, and private string, department, which department this employee belongs to. Okay, these are the few fields that I have added in the employee Pojo. For this, now let's create the getters and setters. So I'll create the getters and setters. If you want this generator options, you can just right click on it and use generate options. For Mac, the shortcut is command N, but for Windows, I think it is command insert. So just check it and use that shortcut to generate this. I'll click on generate and I will generate the getter setters. I'll select all these fields and click on OK. And for this, you can see that the getter setters is created for each and everything. Now what we will do, we will create a controller layer. So within the controller package, let's go ahead and create one controller. I'll create a class and I will mention this class as a employee controller. Hope the spelling is correct. Yes. Okay. So the employee controller is created, and for this employee controller, as is a controller, and with this controller we are going to create the REST APIs. That means we are going to send the response body back based on some of the requests. We will annotate this class with @REST controller. So this means this class is going to be my REST controller. And one more thing I will do is, in the previous example you had seen that in the home controller we had given the mapping for each and every method, and for each and every mapping we had provided the URI. Okay, like on which URI, when the application hits, which particular method has to be invoked and how the processing has to be done. But for employee, what I'm trying to do is, anything comes with /employee should come to this particular controller. So rather than defining all the things in the method itself, that particular base path I will define in the controller itself. So that means anything coming to that employee will come to this controller, and then for each and every different method we can define differently what things to be configured. So I will define request mapping here itself at the class level, and anything coming with /employees will come to this controller. Okay, now controller is always used to handle your request, but once you get the request at your controller level, all your processing should be done at your business layer or at your service layer. So whatever the validations or whatever the processing has to be done, all those things has to be done at your service level. So that's a standard architecture or standard format used across the industry. So we will use that as well. So we will create a service layer, or you can say a business layer, where we will define all our application logic. So the controller layer is defined. So now we have to create a service layer. So for service layer, what we will do is we will follow the interface pattern, where we will define the interface and we will use the implementation, because in the business layer there might be a chance where there are multiple implementations for a particular logic. So we will go ahead with the interface design, where we will create the interface, and for that interface there might be an implementations available. So we will create a package for that, and in that package we will define our service layers. So what I will do, I will create a package at the root level, and I will define a package, and that says it's a service. Okay, and within this service package, what I will do, I will define an interface that says employee service. So I will define employee service, and this is going to be an interface. So this interface is defined. Now for this interface I need to have the implementation. So within the service package, let me create the implementation for this. I'll create a class that says employee service implementation. Okay, and this particular employee service IMPL class is going to implement employee service. Cool, right? Now this employee service implementation is going to be my service layer. So for this I am going to define this @service annotation. It is a stereotype annotation, so with this we will just get to know the information like this is a service layer. But if you go inside, this is always annotated with @component. So whenever this is defined, Spring will know that this class has to be used for our bean creations, and it will be in the Spring's radar. So you can see that our service layers are created. Now whatever the business logic has to be done, we will do all the business logics at this particular point. Now at the controller layer, we will need this particular object, so that whatever the business logic is defined in this layer, we can call those particular methods or the different behaviors it is for it. So as you can see that this is the implementation of the employee service interface. So what we will do is we will inject this particular interface itself. So what it will happen is whenever we will directly inject the interface, whatever the subsequent implementation would be, those implementation for that interface will be injected. If there is only one implementation available, that particular implementation will be directly injected. But if there are multiple implementation, don't worry, we will see later in the course how to handle the multiple implementations as well. So currently we have only one interface, and for that interface we have one implementation. So directly we will use this interface to inject our class. So we'll go to the employee controller, and here I will need the object of a employee service to call the methods of the employee service to do any operation. So I'll define private employee service. Okay, this is the interface that I have defined, and what I will do is I will inject it using the auto wired. Okay, once I do this, whatever the implementation is available, if there is only one implementation, that's fine. Directly that implementation will be injected, that class will be injected here. Okay, so I will get the object of the employee service IMPL here. Cool. Now what I have to do here is I have to create a method that is responsible for saving the employee. Okay, so whatever the data is sent, that data has to be saved in my database. Currently we are not using database or anything. Currently we will store everything in the in-memory, but later in the tutorial, later in the course, we will see how to implement the database as well. So let's create a method that will handle the saving of the employee. So I'll create a method as we seen earlier as well. We will declare with public, and what is the return type? Suppose my return type is employee. Whatever the data is sent, we will send the data back that this particular method has been saved. Sorry, this particular employee has been saved. So we will define employee, and we will define the name of the method that is save. Okay, simple it is. Now here, what will be the input? We are taking the entire employee object as the input. So we'll define employee object here, and this particular employee object will come as the request body. So we'll define request body annotation. So we'll get the entire request body and all the fields over here. Okay, and this method will be called when we are doing the post HTTP request for /employees. So whenever I will do /employees post, this particular method will be called. So that's why we have just defined @post mapping here and no URL, because this is the URL we want to use. If I want to modify this URL, what I can do is, suppose I want to do /abc. So what it will do is it will always call /employees /abc. On that post, this particular method will be called. At this particular point, that resource will be handled. Okay, but what I want is I want /employees post request to handle this. So I'll just remove this here. Okay, so this way it will work. Now at this point, I will get the employee. Now what I want to do is at this particular point, I want to call my business layer at my service layer, and that service layer will be responsible for handling this employee. So what I'll do, I need to have the method. So what I'll do, I will go to the service layer here and I will define a method. So at this point, I will define a method that I want to return employee on save. Okay, and this should take the employee object. Okay, this is the simple method that I have declared, and I need to go and implement this method. So I'll go to the implementation class, that is the employee service IMPL. Here you can see that it started giving me error that you need to implement a method. So I'll go ahead and implement the method, that is the save. Okay, and this is the method that I need to implement. Now what I'll do, I'll create a list here to save all these employees. So let me just define the list here, that list of employee employee employees equals to new array list. So I'll just define one array list. Okay, the spelling mistake is there, so we'll just correct it. Now I've just defined the empty array list here. Now whatever the data will come here, I will try to store all those data in this list. Okay, so now you can see we are in the business layer. So in this business layer, what we will do is we will try to handle this. So here we got the employee. So now you can see that this is the particular save method that we got here. And here at this particular point, we need to do all the validations and all our business logics and everything here. And accordingly, after that, we can go ahead to save into the database or whatever the processing that we need to do, we can do here. Now one validation that I want to do is if this particular employee object is coming, if that particular employee object is having the employee ID or not. If not, I will create the employee ID for it and save it here. So that's some validation that I'm thinking we can do here. So what I'll do, I will just create condition here. So you can see that this is one of the business logic that I'm implementing in a service layer. So if employee dot get employee ID equals to null, or employee dot get employee ID dot is empty. In either of these cases, either it's null or empty, I want to generate it. So what I'll do, I will just do employee dot set employee ID with UUID dot random UUID dot toString. So I've generated one UUID and I'm saving it here. Now once this is done, I will do employees dot add employee. Okay, I am adding the employee in my list, and after that I am returning the employee. You can see that it is a simple method that we have implemented in our service layer. Now this implementation I can directly call from my controller layer. So from the controller layer, what I can do, I can call return employee service dot save method, because we have defined in our interface and we have also defined the implementation for it. So we'll call the save method and we'll pass the employee object to it. Simple. You can see that how easily we were able to implement our controller layer, and we also were easily able to implement our business logic layer, and we are trying to store the data in our list. Okay. Now let's go ahead and start our application and see what is happening here. So we will start our application. And you can see that the application is started with Jetty on port 8081. So we will go to our postman to check this post request. So we'll go to the postman, we'll go to the new request, and here we will do the post request because we have implemented the post request here. And here we will define http colon / localhost colon 8081 / employees, because this is the URL, and we have to pass the body. So we'll go to the body. The body is raw JSON format. So we define the JSON format, and here we can pass the JSON. So we'll check what are the fields. So we'll go here, employee object, and we'll define first name here. We have to pass this way as the JSON format. First name, last name, email ID, department. So let me just copy all those information. Last name, email ID, and the department. Okay, you can see that how simple it is. Now I will just define fields here. Shabir Daudi shabir@gmail.com. My god, spelling mistakes, that's fine. And department, I'll say IT department. And last, there will be no comma. Okay, so this is my payload. Let me just beautify it. Okay, this is my payload and this is my URL. So once I hit send, what it will do is it will come to my employee controller, okay, at this particular point, and this is the post mapping. So this particular method will be called. So let me just hit send, and you can see that we received 200 OK, and we got the employee object back. You can see that the employee ID we had not passed, so employee ID was created using the UUID, and we got the data back. Okay, cool. You can see that the post request is completely working fine. Now let's go ahead and implement the get request. So now what I want is, in the get request, I want to get all the data which are already saved. So what we will do is, if you go to the service layer, okay, so that means we are trying to store all our data in our employee object here. So I want all the data back from this employees list. So we will create a method here for a particular URI that will give us the all the records. So we are going to create one REST API endpoint. So what I'm trying to do is, whenever I will hit /employees with a get request, I will get all the records. Okay, So that's what we are going to build today. So what I'll do, I will just define a method public, and I want a list. So I'll define public list of employee, and I'll define get all employees. Okay. And you can see that for this particular method, I don't need any input parameters because I need all the data. So I'm not going to pass any parameter here. This list I will import from the Java util, and I will annotate this with get mapping because this is going to be a get mapping for /employees. And now what I need is I want to have a method that returns me the list. So what I'll do, I will just do return. I want to return the list and I want to call the employee service my business layer, and it should have a get all employees method. Okay, but currently this get all employees method is not available, right? So we have to create it. IntelliJ IDEA or any of the ID which you were using that allows us to create or generate all these methods very easily. So what we will do, we will use that method. If you are using IntelliJ IDEA, if you just right click here, go to show context menu, and you can see that you will get an option create method get all employees in employee service. So once you hit this, that particular method is created. You can see that this method is created, and if you go to its implementation, you can see we have one implementation for this employee service. So if you go here and you can implement that method. So I'm just implementing this method, and you can see that implementation is there, and now it is returning null. So rather than returning null, what I will do, I will just return my employees, which is my list here, right? So you can see that the implementation for this is also completed. We added the method in our employee service interface. We also added the implementation for it. And if you go to our controller layer, you can see that it is also completely fine. Right. So now let's restart our application to check our API, or if you are using DevTools, then let's wait for this to get processed. Okay, to rebuild the application. So for me, it's already done. So what I will do, I will go to my Postman and I will try to save the same request. So I will try to click on send. One request is saved. I will try to save another data, that is Shivam Kumar shivam@gmail.com and IT department. Let's try to save that as well. Okay, you can see that 2 records are saved. Now what I will do, I will change to get request because we have created the get request here, right? This is the get request for employees list. And if I hit send, you can see that I should be getting list. You can see I'm getting list. This is the first request, this second request. If I use this in the browser, you can see that you are getting both the records. This is the first record and this is the second record, and in the JSON format. Cool, right? You can see that we have just implemented the post mapping and the get mapping for a particular CRUD operation. Now let's implement one more method where we will try to get a particular employee based on the ID that is provided. So currently you can see that we are getting all the employees currently, right? Now what if I do slash and if I give any of the ID, then for that particular ID, I will get a particular record. Okay, so that's what we are going to build in the next API, where based on the ID provided, we will get a particular employee record. So let's go ahead and go to the IntelliJ IDEA. And here I will create a new get mapping. Okay, so what I will define here is public employee, because I just need one employee, and I'll just define the method name as get employee by ID. Okay, because we are going to get the employee based on the ID provided. And what I will do is I need to get the ID as well. So in the input parameter, I will mention that I need a particular ID. And here in the get mapping, we will define here get mapping, and here is something that we need a ID, right? Because after /employees mentioned here, I need a particular ID. So after this, I need ID here as a path variable. And you already know that whenever we mention path ID, it's a mandatory field, right? So that's a path variable. So we need to define a path variable annotation here. So we'll define a path variable annotation. Okay. Now from here we need to return the employee object. So we'll define return employee service dot get employee by ID. Okay, it's a simple method that I have defined, but this method is not available in our employee interface, that is employee service, and the implementation is also not available. So you can see that create method, I'm getting a suggestion that is create method get employee by ID in employee service, and which is something that I intend to do. So I'll just create on that, which will create a method here, and then I will go to the implementation class for this interface, and I will implement the method as well. Okay, so you can see that this particular employee by ID is created. Now what I want is, from this list I want to get that particular object. So I'll just define employees dot stream. To implement this using streams, there are multiple ways, but I'm just using a filter operation to filter that out and to get that result. So I'm just trying to do filter based on what? Filter based on the employee, where employee dot get employee ID. Okay, and one more thing we forgot here is that we had to pass the employee ID here, right? Because with what we will compare. So this type of mistakes always happen. Don't worry, you can always go ahead to your controller and you can pass the ID here. So pass the ID and go to the get employee by ID method, and here just take this as a string ID, go to the implementation for it, and let's take the string ID here. Okay, and I need to compare this ID dot equals with the ID provided. Okay, once that is done, what I need to do is dot, I just need the first object of it, so I'll just do find first dot get. Okay, so you can see that it's just a simple stream that I provided, where with the streams of employees I'm just filtering out the particular object with which the employee ID is matching. I'm taking the first out of it and I'm just returning the data back. So if I go back to my controller, okay, and you can see that this particular method is implemented, and what I will do, I will go back to my postman and let's do this. So before this I need to add the data because we are using the in-memory for currently. So I'll just hit send to save the data, and if I do get request for that, I'll be getting that particular record here, right? Now what I will do, I will just copy this ID, I will do get employees slash particular ID, and if I hit send, there is some issue here, right? Let's see what is the issue. Let me just go back to the previous one. If I do get employees, and you can see that this is the particular data. Okay, and if you go back to our method, what we had done here in the implementation, okay, let me just try to do with the equals ignore case here, okay, with the ID, and let me restart my application and check. Okay, the application is already restarted. If I go to my controller layer, I'm getting the path variable as the ID itself, and if I try to post the data first, okay, the data is posted, this is the ID. If I go with the get request for all the employees, I'm getting this request, and if I copy this with slash, and I'm not able to get the data, that is great. You can see that we did the wrong thing here, and the issue was we used the get email. It should be get employee ID. Okay, so that was a mistake. So don't worry guys, sometimes we will make mistakes. So this is the employee ID that we are using now. Now it should completely work fine. If I go back to my postman, okay, let me just try to store the data. Let me just remove this URL, and we will do post here, and we will hit send. The data is saved here. Now with this ID, if I do get, I should be able to get the data. Yeah, post is not allowed, that's fine, we need to do get here. So we'll do the get method and we are able to get the record here. Okay, cool. You can see that it's completely working fine. But what if when the data is not available, right? We were getting the earlier as well. So if I'm giving any particular ID, the data is not available, and you can see that I'm getting a huge error here, right? So this is something that we need to handle. So in the next video, we will handle this. So now in this session, let's handle the exception that we are getting when there is no records available. So we'll go to the IntelliJ IDEA, and within this method itself, you can see that whenever we are doing get, that's fine. But what about if the data is not available, right? So at the time what I can do is, rather than using get, because you can see that this is find first is something that is sending the optional. Okay, so rather than using get, what I can do, or else here, or else throw the exception. Okay, this is something that I have defined. So I can define this way, like rather than getting, if the data is not available, let's throw the exception. So by default I can use new runtime exception. Okay, and you can pass that employee not found with ID provided. Okay, it's a simple thing that I'm doing here, but generally when you are building your application, you will not use the standard exceptions or the runtime exception. You will create your own custom exceptions to handle that. Okay, so what we will do, we will create our own custom exception, and that custom exception we will throw from here, and we will handle that exception in the REST APIs, like how to handle that. So to handle such kind of scenarios, we need to have custom exception. And what I will do, I will create, and for this what I will do, I will create a new package, and in that package I will store all the exception related classes. So in this package I will just mention this is an exception or an error, whatever you want you can define here. Okay, I'm just defining the error here, and in this error package let me just define a class that's a custom exception, and I'll define employee not found exception. Okay, this is a simple class that I've defined here, and this particular class, let me just refactor this spelling mistake. It should be employee not found exception, and this will extends runtime exception. And this particular class will have one constructor which will take the message as the input. So I'll just define public constructor employee not found exception, which will take string message, and we will call the super of it. So you can see that it's a simple exception that I have defined here. Okay, and this is something we need to pass back. Okay, so what I will do is, if I go to my service IMPL, and whenever that particular employee is not available, rather than throwing runtime exception, I will throw employee not found exception. You can see that now code looks really clean, and from this we will be able to understand as well, okay, this is an exception where employee is not found. Runtime exception is very generic, right? But here you can see that from here we are able to understand. But what about from the API? You can see that whenever we got the request, it's a huge request, and we are not able to understand much from here. Okay, so we have to create a particular response as well. So whenever there are exceptions, and whenever we send the response back for this kind of exceptions, there is a particular way that we can represent it. Okay, so that representation also we need to define, like what would be the response body when there is an exception. So for this we have to use the controller advice. So if you don't know about the advices, it is the concept of the AOP, that is the aspect oriented programming, where you can create the cross-cutting concerns or handle the cross-cutting concerns outside your standard code. So what I'm trying to do is, for my controller, I am trying to create the advice around it. So what that advice will do is, that's a cross-cutting concern which I'm trying to write outside my controller. So whenever there is an exception, I don't have to handle all those exceptions within my controller. There is an advice created, and for all those controllers which I have in my system, the advice is there, and that advice will run whenever there is an exception to it. So whenever a particular exception occurs, that particular advice will run, and it will send the response back. So that's what we are going to do. So we are going to create a controller advice that will handle all those particular things for us. So what I'll do, I'll create a class that's the REST request response handler exception. So within the error package itself, I'll create a class that is REST response entity exception handler. Okay, so this is a simple class that I'm defining. You can give any name, and this class will extends response entity exception handler. Okay, simple it is. Now this class is something that we are using to handle all our exceptions, right? So we will annotate this with the controller advice as I have defined earlier. Okay, so this particular class will run whenever there are cross-cutting concerns to handle for a particular controllers. Okay. And now what is my cross-cutting concern here is I want to handle that exception. So whenever for a particular request that a particular exception is thrown, that is the employee not found exception, this class should be able to handle that for me. Okay. I'm not writing all those logics in my controller layer because it is not part of the controller. Controller is just to handle all my requests for me. Okay, so that's why we are doing this way here. And now here we will create a method that will handle that particular exception for me. So I need to create a method. And what is the return type? So what I need in a return type is I want to send a particular object back. That object should have some of the information from which we should be able to understand what is the particular error message. So ideally we want to send a particular message back, that is the exception message that we have defined. And we can also send what is the status code for it. You can define all the different fields as well what you want to send, but for now what we are going to do is we are going to define these two fields, so you will get the understanding how those things work, and you can always implement on it. You can always enhance these functionalities based on your requirements. So what I will do, I will create the model for it because I want to send the data back, right? So for that I'll create a model and I will name this as the error message. Okay, simple. Now within this error message, what I want to do is I want to have HTTP status, and this is the part of the org Spring Framework HTTP status and private string message. You can have other properties as well which you want to pass back, but for now this is more than enough to understand how that particular thing works. And for this what I will do is I will create the getter setters. Okay, so you can see that the getter setters are created and I can use this error message to send the data back. So within this REST response entity exception handler, I will use error message to send the data back. Okay, and I will name the method employee not found handler. Okay, and this is my method. Now for this particular method we need to inject which particular exception we want to handle. So we want to handle employee not found exception, right? So we are injecting that exception. Now this particular method also needs to be annotated for Spring to understand what we have to do. Okay, so this particular method is the exception handler for what? So we need to define the annotation, that is the exception handler. So this is the exception handler method, and for which exception? So that is the employee not found exception dot class. Okay, and this method will return the response body in return. So that's why we have defined response body, and we also want to have a particular status as well to return. If you don't define this, by default it will send as a 200, but I want a different status message to be returned for HTTP status message. So I'll just define response status. Okay, and that status has to be HTTP status dot not found. Okay, that is the 404 not found. Now you can see that we have annotated with all the details which we need. Now we need to create the error message object, and that we need to send back. So we'll define error message equals to new error message, and now you can see that there is, for this error message there is only a default constructor available, but I have two fields. So for that I will create a constructor for it. So I'll go to the error message and there are only getter setters created, right? So what I'll do, I will create a constructor. First I'll create a constructor without any fields, that is a default constructor, and I will create a constructor with my two fields as well, that is the status and message. Okay, now if I go back to my REST response entity exception handler, here I can pass two things, that is the HTTP status dot not found and the message itself, exception dot get message. Okay, now these two things are defined, and now what I have to do, I just have to return this message object. So you can see that it's very simple thing. What we did was, if you go to my service layer, okay, whenever the employee is not available, I am throwing the employee not found exception, but this employee not found exception has to be handled somewhere. Okay, if we try to handle all this kind of exceptions at the controller layer itself, it's not feasible because we have to handle a lot of things. So for that we are using the AOP concept, that is the aspect oriented programming concept, where we are defining the advice for our controllers. So that's why we are using @controller advice annotation. So that advice will work whenever there are any exceptions. So we are creating that class for our exception handler only. So whenever we are raising the exception or whenever there is an exception in our program, that particular class will kick in. It will try to figure out which particular exception handler has to be called based on the exception that has been thrown, and it will create the response object for us and it will send the data back, so that from the client side, whoever is getting the request, they will get the exact information which we needed to send from our application. So rather than passing the generic data, this will be the proper data that will be sent by the application. So now let's go and check this. So if I just remove this and if I convert to post and if I hit send, that means my data is created, right? So if I try to get the data with this ID itself using the get method, I should be able to get the data. But if I change this ID, that means when the data is not available, I should be getting the proper error message. You can see that now I'm getting the proper error message. Earlier you had seen that it was really big and it was not understandable as well. Now you can see that it's very simple. We got the status message as well, status code, that is 404 not found rather than 200 okay. And status also we got, that is this is not found, and message also we got that employee not found with the ID this. Now you can see that with this it's easily understandable what is going with our application. Now what if there are generic exceptions? So we need to handle the generic exceptions as well, right? So what I will do is, we had already handled one exception, so let's try to handle generic exception as well. So if you go to our IntelliJ idea, this is something that we implemented for one of the exception, that is the employee not found exception. Now let's handle for the generic exception as well. So what I'll do, I will copy this entire thing. Okay, it's very simple, okay, don't worry. So what I'll do, rather than employee not found exception, I will define that general exception itself. So whenever there is exception overall, this should be called, okay. And rather than employee not found exception, we will pass the exception here, okay. And rather than not found, this will be internal server error, because this is a general exception, and for that we pass the 500, that is internal server error. And we will pass the same thing here as well. So you can see that we created the another method. And you can see it's very easy, right? Earlier it was employee not found exception, class and all those things. And here what I will do, I will change the name, handle generic, or rather than generic exception handler. Okay, this is a generic exception handler which will pass the error message again, which will handle the exception class, and in return this will be also getting the exception as an injection here. So we are injecting the exception here and we are passing the data with the internal server error. Now to test this, what we will do is, rather than passing the employee not found exception, I will just pass the runtime exception here. Okay, now let's test this. I will go to my Postman and let me just directly test this. So you can see that earlier what we had got was not found and employee not found with ID, and where we were getting the status as 404. But now if I hit send, you can see that I'm getting internal server error with 500 internal server error as the status code. So you can see that this is handled by my new method that I had created in my REST response entity, that is this one. Okay, now if I again change back to my employee not found, so this time this should be sent back. Okay, the changes are reflected now. Let's test this again. And you can see that now I'm getting 404 not found exception. So if you want, there are multiple exceptions, you can add all those multiple exception handlers, and accordingly you can send the data back and your application would be able to handle all your exceptions. So this is how you would be implementing exception handling in your Spring Boot with the REST APIs. Now let's implement the another API for deleting the data. So for that we will go to our IntelliJ idea, we'll go to our controller, that is the employee controller, and here we will create a delete mapping. Okay, so we had already created the get mapping here for getting the employee, for getting all the employees and posting the data. Let's do for deleting. So here I'll define public, and what I want to return string here and delete employee by ID is the method. Okay, and here as well, what I want to do is I want to do delete mapping. So I'll just define delete mapping here. And what I want to delete based on the ID provided. So here as well, I will take the path variable. That's the ID. And here I will define a path variable annotation. And I will take the string in the ID here. Okay, you can see it's simple thing. Now I will do return employee service dot delete employee by ID. Okay, the method is created. I will pass the ID here and I will create a method in my employee service. Okay, create a method. Yes. Now if I'll go to my implementation, I need to implement this method. So let's go ahead and implement the method. Okay. Okay, here what I'll do now, I need to take the employee object from this employee list and I had to remove that employee. Okay, so that's something that I have to do. So what I will do, I will create the employee object here and equals to, I'll loop through employees dot stream dot filter for the employee. I'll mention E here, that would be easy. So E dot get employee ID dot equals ignore case with the ID provided. Okay, once I get this, I will do find first then dot get. So you can see that at this point I'll get a particular employee. So that particular employee I will remove from the list. So employees dot remove employee. Okay, so that particular employee has been removed from my list and I will send the data back that employee deleted with the ID passed. Okay, you can see that the simple method we created, we took the employee from the list and then we removed the employee from the list and we send the data back that employee deleted with the ID which was passed. Okay, and the DevTools has reflected the changes, so we will check this. So we'll go to the postman here, we will just change the URL, we will do the post request here and we will save the Shivam here first. Okay, the data is saved. I will save Shabbir Daudi shabbir@gmail.com and I will save the data. Okay, the two datas are saved. If I get the data, you can see that I am getting two records here, right? One is Shabbir and one is Shivam. So let's delete Shivam from here. So I will get the ID from here and I will pass the ID /ID as it's a path variable and I will change the mapping to delete. Okay, because we had mentioned delete mapping. And once I hit send, you can see that I'm getting the data that is employee deleted with the ID this. If I now do get request without the ID, I should be only getting one request. That is one response, one data. So you can see that I'm getting only one record, that is the Shabbir. So you can see that we are easily able to delete the data using the delete handler as well.